My name is Peter Hansen. I'm a consultant and architect at Rehfeldt, a Danish BI consultancy agency. I have worked with BI and data warehouse and automation of these things for almost a decade. And I'm very happy to now be working with Biml. Today, I'm going to talk a bit high level about why we automate in the first place, what parts of data warehousing and ETL processes that we may automate, how to do it, and some things we might consider on the way. For instance, moving towards a more modular approach to doing these projects. After that, I'm going to go through a small business case, which is actually the project I'm on right now. You will be introduced to the project, why we automate in this project, why we chose to do it with BIML, and then talk a bit about the considerations and how we did it. So, let's just get started. Why automate data warehousing and ETL processes in the first place? Well, there are probably many reasons to do this, but these are the main reasons I usually encounter when people do this. Usually you want to enforce standard patterns, best practices, design decisions, and most often the first step to do that is by doing it in written manuals. And as we all know, these manuals aren't often used, they aren't followed, they aren't maintained, and if they are maintained, then the code that follow these manuals aren't necessarily maintained as well. So by applying these standard patterns and routines into our code instead of manuals, we can actually enforce them across our projects. There's also, especially on larger projects which are complex, there's a significant speed gain with regard to how long it takes to develop these ETL and data warehouse patterns. Simply because there's a lot of economy of scale and there is a lot of reusability once we start to automate these things. Also, when we automate, we are less vulnerable to changes during the project. As the project grows and the data warehouse gets more complex, as the business logic that is applied gets more complex, the general complexity simply grows with time. And therefore, when we try to change something, it simply costs more the longer the project has run, if we do it manually. On the other hand, if we automate these things, the cost of actually changing direction, changing data model, getting a new source, rethinking some business logic, or applying new patterns to the way we do slowly changing dimensions, or the way we do inferred handling, the cost of that is usually the same, and it's much, much lower. So we are not hit as hard by this rising complexity over time. It's a very important point. Because this benefit actually kicks in also if it's not necessarily a very huge project, but simply because it has run over time, the complexity has risen, and it really hurts to do any kind of change. The deployment scenario isn't necessarily that important today as it was perhaps 5 or 8 years ago, because everything is cloud-based now. Everything is centralized. But if you have a standard solution, some standard patterns that you want to apply locally in local environments, and you want to ship this product, and you actually want it to be configurable locally, then you don't want to send all your consultants out doing it all the time. You want to be able to have some sort of automation. Maybe you have a simple GUI, but you want the code to be able to automate itself locally, so that you can configure it instead of developing it. We all heard about this next point. Actually, we all want to do less monkey work. We want to apply our brains and our energy and our time where it actually matters the most. We want to be able to use our time applying business logic to our code and not doing all of this repetitive, mindless and boring work. There are many, many benefits from doing this. It's much easier to actually hold on to your good developers and your smart guys if they are challenged. If they're challenged, they also develop much faster, they think it's fun, and the quality and productivity of their work is also higher. No one wants to do a lot of repetitive work all the time. So by letting the the code do this repetitive work for us, we can start doing things that are interesting and that actually matter to the customer. So what we actually want to achieve is we want to go in a direction where we configure much, much more and develop much, much less. And what this means is that not only is the customer actually able to start configuring some of these things early on in the project, you can go to the customer and say, you are now responsible for applying this configuration. You can now tell the customer to simply configure which columns has this and this kind of slowly changing dimensions logic applied to it. Which sources and entities do we want to be able to insert unknown members or inferred members and so on. We can do this so that it's configurable, and not only is the customer able to do it, but you can also staff your project with junior developers. You don't have to let your junior developers become some sort of architect some of the time. They don't have to understand all the underlying patterns that suddenly apply to doing a simple lookup, because you have expanded your data warehouse architecture, because now it has to handle all kinds of special scenarios. So, what do we automate with regards to data warehousing and the ETL process? Well, first off, we have to automate the creation of our physical layer. We want to be able to control in our metadata or somewhere else what tables, what databases, what schemas, columns, data types, constraints, and so on are actually created. And of course we want to do it because it's much faster and it's correct all the time. But we also want to do it because once we start automating the ETL logic, we want to make sure that the ETL logic and the physical structures logic is actually in sync. Otherwise, we have problems all the time. And I'll return to how we can actually do that. But it's very important that you don't. In the beginning, you can start just automating simple ETL flows. But if you do it on a larger scale, you have to make sure that these are in sync. But you can also, once you've done those things, you can start looking at what about the environmental settings. There's flow logic. In what order do we have to execute our batches or our loads for certain areas or source systems? How do we apply security, all those things. We can also start automating those things. And finally, testing isn't something that's, of course we test, our ETL guys of course test this thing, but we don't automate it. Usually you do your test by maybe some ETL guy A has done a flow, and then ETL guy B reviews it. Then they start to try running it and see, oh, there's data in our table and there's not all that many unknowns, and it pretty much looks fine. Then they ask the customer to review it and they say, oh, it looks fine. But what we want to achieve with automation is that we can now apply patterns, also testing patterns on large scale, and we can do it all the time. I mean, continuous integration is something that you do when you do developing of almost everything else, but we don't always do it in data warehousing ETL. We want to be able to do regression testing. We want to know that now that we have added a new source system, maybe it's number 17, I don't know, that it doesn't change something with regard to the third source system that we added. We can't manually test everything as the system grows, then you have to hire 3 people to just do testing all the time manually. We want to be able to structure tests of business logic. We want to be able to go to the customer and say, dear customer, this entity, what business rules apply? Is it okay that the average class only has 2 pupils in it? I don't know. But the customer knows these things. So if we can structure this and the customer can start configuring these business logical tests, then we can just do it during our continuous integration builds every day or maybe several times a day. And we know instantly if we've applied some new logic that makes something wrong. We can start testing for logical errors much, much easier. And they are the ones that usually take a long time to find. We can all write code that just checks if there's a null in a column or a foreign key column only has unknowns. But they're just technical and architectural tests. We want to be able to apply business logic tests as well. And we can do that through automation. So how do we automate more in general, well, it's really, really nice that we now start seeing products that help us automate. Now we start to get software like Mist, and we start to have structured abstraction layers like Biml. That it really helps a lot, because we don't have to sit down and do all of this stuff over and over again ourselves everywhere. But we still have to be able to structure our metadata in order to really achieve something on a larger scale. And that can be quite challenging. We actually have to have a very strong distinction between these kinds of layers in our architecture and in our solution. We want to, if it's possible, to define our business logic and our business rules separately from everything else. If we define our business logics the same place as we design, I don't know, system-specific logic, if we write our business logic in SQL code and we then change platform and we do something else, then we want to upgrade our system and we have to go through all our business logic because now the syntax is different. It has nothing to do with each other. So we want these layers to be defined on their own. Also, we would like to be able to define data warehouse logic independent from all the other things, if it's possible. We can try to achieve this. So we have to remove the strong coupling between these layers. We have to design our solution so that the physical structures and the ETL logic is in sync, of course. And then we can consider some of these things. If we decide to build a new metadata-driven solution from scratch, we want to create our own metadata store to actually start automating our data warehouse and ETL solutions. We should be able to match our complexity of our framework with the complexity and scale of the project that we want to apply it to. Usually what happens when we start automating things is that we start automating more and more. We start having some sort of reference architecture that is now so huge that it can pretty much be used everywhere in all of our projects. But if, I don't know, 20–25%, if some of our projects are actually small, it makes no sense to apply this very, very huge standard framework, because the customer won't have no idea why is it so big, why is it so complex, you cannot debug it, you cannot really understand what's going on. So if you start from scratch to create a metadata framework, you probably start thinking about how can I insert some kind of logic to control scalability, so that I'm able to apply a framework that actually matches that of the project. And one way to do this is also to say, is it possible to switch between architectures? What if a customer says, well, this very big and huge architecture you show us, it can handle everything, it has an enterprise data warehouse, that makes no sense to us. We actually want to have a Kimball approach, not because we are in love with the architecture necessarily, but because we want to, project-wise, to have an incremental approach. We want to do this in small steps. We want to start in this apartment and build a data mart, and then we want to let these guys try and do it. And then later on we can start consolidating these things. Then your architecture doesn't fit the context. So if you can make it possible to configure in your metadata framework which architecture these rules apply to, it would make really great sense. On the project I'm on right now, we actually started doing this from day one. We're not really using it yet because the project hasn't changed that much, but it makes sense to us that we can then say, oh, now I'm working on the test architecture, now I'm working on this version 3 of our architecture. Then in version 4, I've actually added a lot of logic to do something. It doesn't work, I can't fix it, but the customer needs some data. Then I can switch back to architecture 3. It makes perfect sense to think about these things. So, I talked about this modular approach, and I talked about how sometimes logic from all these different paradigms, business logic, system logic, data logic, is sort of crammed together where they don't, where they shouldn't be. This is I don't know what you call them in Sweden. In Denmark we have something called a cowboy consultant. And it's this consultant from the beginning of the new millennia that controls everything. They're perfect, they are very expensive, but they know their stuff, they can do everything. They can talk business with the customer. They know how to do accounting, they know debit and credit, they know all these kind of things. They know a lot of the systems from which we gather data because they've tried a few things. They know their systems, they can do Oracle, they can do SQL Server, they can do MySQL, they can do all the stuff, SAP and so on. And they know how to do data warehousing. They're all architects. They know all the standard patterns, they can apply all of them, and they can answer all of these different types of patterns across all these domains and areas. But what happens when they start developing is they create some sort of ETL flow, probably sys. So we have a sys package, and it does all of this. It deals with business logic. When a special school is null, that means it's a standard school, perhaps. But that's business logic. Then there's some logic that's defined on what is the syntax for this system, how is the source data structured, how do I want to do inferred handling and so on. All of this knowledge is actually crammed into the very same sys package. And there are so many disadvantages to this because you can't query it. You can say, how many places does this business logic apply? How many places have I defined this? Now I want to do inferred handling differently. I want to apply slowly changing dimensions type 2 in a new way. I have to manually go through all of this if I can find it. And usually the cases I can't find all of it because different persons have done it differently. So now I only upgrade perhaps 80% of my flows. So what I suggest that we start moving towards is a more modular approach where we actually define these areas, these kinds of logic in a separate layer. It doesn't have to be a separate database, but consider to differentiate between them somehow, systematically. So that you can have perhaps your history in separate tables. We all know that design. You start differentiating between your history keys and your entity keys. Once you do that, you can start actually using different kinds of history and applying them when you want them. You can start simply by considering business logic such as filters. What kinds of entities do I want to load from this source system? How do I want to configure the link between source systems and so on? You can start doing some of that. And then there's a lot of business logic that you can't, of course, from the beginning configure. You can't structure it well enough. But you can start doing it. Then there are different kinds of metadata. There's metadata that's descriptive, such as process lineage and data lineage. What if, say, a month into a project, the data it's online, it's being used, and now the customer wants to add data lineage because all of these end users are starting asking questions, where does this data come from? Why does it look like this? It doesn't look like this in my OLTP system. So we say we have to apply data lineage. What do you say? How long does it take? What are the risks of doing this so long into the project? If you actually automate, you can just on the fly say, I now have a pattern for applying data lineage. Or I can do it to process lineage. So I can make a website or page where all of this, because we actually use configurable metadata to build everything, to do our scripting. So our configurable metadata just of a sudden becomes descriptive with regard to doing process lineage. So if we can let the end user get access to some of the configurable metadata that we actually already have structured and is now using to automate our processes, they can understand what is going on as this data is being loaded through the source systems, through our layers, and what kinds of logic is now being applied to it. You can do lots of things, language settings and so on. Of course, there are other areas to modulate. So, I will now go through this case. This is the project I'm currently on. It started in November with a POC. We did a pilot, and now we are running at full speed. A Danish ministry, which concerns itself with educational data, has a goal that by 2020, all relevant data from all the systems that has anything to do with our educational system has become available to a broader group of end users than is actually the case today. Today we have an entire department that does nothing else but do analysis and extracts from all sorts of source systems in order to answer questions from ministry employees, journalists, and so on. It's very expensive. Sometimes they get it wrong. Sometimes these data aren't in sync, and sometimes you have a news story that is wrong, or some guy makes a wrong decision because this simply isn't the case. So we have data about education, schools, universities, what kinds of classes they offer, how many pupils get an A or whatever it's called. I don't know what scale you have in Sweden. In this case, we actually enter into the same project group as the customer. So we have the shared project group, and the customers guys are going to do some of the work. Of course, we are going to do some of the more technical work, and they're going to be doing some data modeling and domain analysis and so on. We use SQL Server 2012. We have to use integration services, and we like that. And early on, we actually the customer decided that we wanted to have a model where we had an enterprise data warehouse core and then this denormalized data mart layer. Simply because they had a notion that they didn't necessarily know all of these source systems. They didn't know the domain, so maybe there were going to be a few changes. So in order to make it a bit flexible, they thought, we put this in. You can agree or not to. So this is the scene. We talked for a bit and decided to try to convince the customer to automate all our data warehouse structures and all of our ETL processes. And we did this because we saw some challenges right ahead. First off, there isn't really any focus on what kinds of reports they want to do, what kind of analysis they want to be able to do. They don't know who the end users are. They just know that data from these source systems are going to be available in some form. And there are many different domain models that overlap. And there are many different systems, and they are used very, very differently. The domain isn't fully understood. It isn't mapped. It isn't modeled. And like I said, it's likely to change over time. Also, they don't really know right away what kind of data warehouse functionality that's going to be required later on. They haven't decided if they want to pay for slowly changing dimensions type 2 or late arriving dimension and so on. They just want to be able to take it as it comes, and when they realize there's a need, they want us to be able to apply it. This project is going to get very big very soon, so there's going to be not just complexity but also a size issue. And once we are done, once we actually deliver this, the customer wants to be able to do support and further development of the data warehouse without our help. So we concluded that we definitely need to be able to do agile development, because we have to be able to apply changes not only to the domain models, but also to the way we do data warehouse functionality and what functionality actually applies. We need to reduce complexity so that the customer can start doing things. They have to start having ownership of this process right now, because in a couple of years we'll be gone. So we have to be able to configure things. The customer has to be able to sit down and configure things and not do real development, because they can't do that. And finally, our solution needs to come up with something and deliver something that isn't difficult to understand. It has to look like a guy sat down and did all of these sys packages manually. So in order to achieve all of these things, we decided to use Biml. So why did we do that? There are many reasons. And this first reason actually I think is very interesting. Because I've been on a project a couple of years before this, also a very, very huge project. We were, I don't know, 35, 40 developers. And we also automated the ETL in that project. But because we used Automatica, and I couldn't really find any framework for automating Automatica flows, we had some .NET guys sit down in a corner and start doing an automation framework for us. It turned out they used 5 times as much time as we actually thought they would. It became very, very expensive. And it took 6 months before we actually started using the framework for doing actual ETL development or configuration. And they were an extreme bottleneck. They had no clue about data warehousing. They learned on the way, of course. So there were so many communication issues, and it took a long time. It was a big problem. Now it actually starts being worth it, but it was hell. With Biml, we hope to have a more democratic process, because you don't have to know a lot of programming languages in order to be able to start automating using Biml. You simply know how to read and perhaps write in an XML schema, and pretty much all ETL guys somehow has seen an XML file, I hope. You have to probably be able to write a few kinds of .NET code, VB or C#, in order to retrieve your data, in order to do some simple loops. That's it. That's good, because then we don't have these reduced bottlenecks. It means that more of the developers on this project is able to work with the framework, to apply their ideas and their knowledge, and we are able to share knowledge. Now it isn't just a few or maybe only one of the ETL guys, probably the architect, who sits in a corner and starts thinking about patterns and how to apply these abstraction layers. Now everyone is going to do it, and we're going to work together doing it. That's very powerful. This knowledge sharing is very important. Also, like I said, usually it can take a long time before you have something to show the customer or the project lead or whoever makes decisions about, are we going to automate or not. With Biml, and I didn't use Mist, I just used the free version. I did a POC in a couple of days. It wasn't perfect, there was a lot of assumptions, but I was able to auto-generate sys packages, flows into different layers, and I was able to show that I could configure different things. It was very powerful. And in a few weeks we had the first version. We had the first version of our metadata store, and we're actually still using about 80 or 90% of that metadata in the work that we do today. So we had sort of the first real version in only a couple of weeks. Then we started adding and adding and adding functionality and features. And again, like I said, the source code for this, it isn't some huge .NET framework with thousands of classes. It's XML. Everyone can read it, everyone can understand it, and you're able to structure it very, very easily. And also this last point, I've heard about Biml before. I never really worked with it professionally before this. But it looks sort of, there's a lot of stuff going on in the community. People are talking about it, people are starting using it. You can find plenty of guidelines and examples and code snippets everywhere on the internet, and you can draw creativity and inspiration from that. And I also think that in a couple of years, when we have probably gone from this project and some other consultant takes over, it's very likely that he or her has probably seen some Biml somewhere. I hope that's going to be the case. So, we had some further considerations that we actually went and talked to the customer about. Like I said, we were very interested in the skills required to develop this automation framework. And we were also interested in how soon could we show something so that we actually were allowed to do it. And we thought about different scenarios. Of course, we all want to compare to this control hamster group down here, which is manual sys development. We knew we weren't going to do it, but we wanted to see how did it compare to that. We could do Biml script. We could do dynamic sys packages, which some of us probably have done at one point or another. We could auto-generate via EC API, like some of you may have seen. Or we could have some .NET guys just do our entire new framework from scratch and either automate sys XML or use some objects. And we thought about it and sort of tried to communicate this to the customer. Definitely doing this through .NET code is going to require more skills. You're going to need these guys. You can't just take any ETL guy and have them do this. And it will take some time before you actually have something to show. On the other hand, sort of the same amount of skills or special skills are required to do Biml script or dynamic sys packages. They're just different kinds of skills. Good ETL guys can do this. And normal ETL guys with a bit of .NET or XML experience will be able to do that. So this was sort of a tie for the customer. Why do we do this? It's standard. This is a third-party thing. Why do we want to? Why we use that? Then we said, we are actually also concerned with the complexity of the output of this that we are going to automate. With dynamic sys packages, the complexity is, I think, very often very high. People can't necessarily just open up a dynamic sys package and understand what's going on. Definitely not a junior consultant or developer. And if you haven't done it the same way all around, it gets very messy, and I don't think the customer would want to do that. Of course, if you've automated your sys packages so they look like they were done manually, no matter how you did it, they're going to be nice and clean, and they're very, very easy to read. And the reason why manual sys packages is up here, where there's more complexity, is of course that as the project grows and it gets more complex and large, this complexity is going to grow as well, because there are going to be new people doing this. They're not going to follow the same standards. They're going to do it a bit differently. Maybe there were some errors that you wanted to correct and you only did it someplace. And sooner or later, this complexity is so high that you want to start from scratch in some areas. Whereas down here, the complexity is the same, no matter how big or complex the project as a whole is. So based on these two, we actually ended up doing it with Biml. So how did we do it, with Biml in this particular case? Like I said, you always have to consider how to structure your metadata. Otherwise, you will only get small, quick gains. But if you want to do a large setup, you want to have your metadata very, very structured. So we start out with the metadata layer, pretty separate areas, and it's also matched in our architecture, of course. So we have knowledge about everything down here. We know about the physical structures, we know about the links between them, what lookups we're going to use, what business keys come from which system, and so on. We know everything down here. We know our column mappings, we know our versions, and so on. And we also, down here, have templates for all of the technical stuff. How do we do a type 2 history lookup if it's going to go fast? How do we do it if we want it to be easy to read, and so on? We have templates. And in order to make sure that this ETL code that we generate and the physical structures that it's going to move data to and from are in sync, we put in this abstraction layer of functions and stored procedures, so that everything that's used to generate our ETL and to generate our physical structures is actually the same code. It's very powerful because now they are always in sync. It's the same worldview on our metadata that this abstraction layer actually provides us with. And our Biml templates, of course, structures all the stuff that we want to do. If I had known more about this, if I had missed, these templates would have been much, much easier. What I wanted to do from the beginning was I thought, oh, I want to do a lookup in Biml and then store it somewhere. Then I want to do a source and store it somewhere. Then I do a template for a target, inferred members handling, and so on. And then I want to stitch them all together. We couldn't really do that. So now we end up with rather large Biml XML structures that we then apply, and there's a lot of redundancy. As you will see later, as Scott is going to show you, you can use something called transformers to make your templates more modular. So now I'm going to go back to this customer and tell them to buy this product. But you will soon see why that's going to be a good idea. But that's sort of the only thing that I'm sorry about in this setup, that I haven't been able to really break down our Biml templates. So that hurts a bit. With regard to how we structured our metadata, it turns out really, like I said, I've done this for many years, and usually we end up at a high level with something like these three areas. There's something that describes the design. You have this, you know the structure of your source system. You know the structure of your data warehouse layers. You also want to configure your ETL. So there's a lot of column mappings and so on in there. And then you have all of your framework stuff that it includes the templates and the design logic for several things. But pretty much it covers what we have now. We have 3 schemas in our metadata store, and it's these 3 schemas. Here's an example of what we generated with our framework so far. As you can see, it's pretty nice to look at. It's well structured, it's easy to read. On the person over there, you can see we do not have a truncate because it's configurable. The customer said, with regard to how we receive this data, we're not going to truncate stuff. There's a simple data flow task, and then due to the pattern that's applied on these tables, we need to do an execute SQL task to do our update afterwards. There are other patterns. We considered doing a merge pattern instead because it's faster. But the customer actually liked to be able to go into SYS, open it up, and actually clicking on a lookup and task and see, oh, all of these lines connect stuff. They like that graphical interface. So we couldn't really do everything in a merge statement because they said, we want to do SYS. We said that. Integration services, we're not doing SQL. So we sort of have that hybrid where we end up putting all of the rows that have to be updated into a separate update table, and then we simply do a join merge or a join update afterwards. But this is an example of we simply want to do lookups, but we don't define lookups anywhere in our metadata. What we do instead is that in our data warehouse model, we have relationships. They're from one surrogate key to a foreign key. And we also, with each relationship in our data warehouse layer, is mapped to a relationship in the source layer. So that we know exactly what the business keys we're going to use in our lookup is going to be. So if the model changes, the lookups change. We don't have to consider it as flow logic because a lookup isn't really flow logic. A lookup is logic that's based on the models. So by pushing it in this direction, we can say to the customer, you just go and maintain these models. Then we automate every day, and the next day we actually have new lookups or new business keys in those lookups. And we don't have to do anything. And this also shows that we can apply patterns. This pattern with, if I want to do a merge or something else instead, I can just apply that architecture to our project. But the ETL guys won't have to change anything because the metadata about this, the business logic, the data model logic is exactly the same. I just changed my Biml template instead, and then it does something else technically, but the customer doesn't have to know it. He just sees now our flows run faster, or now we don't have that error or whatever it is. So we are actually able to change and expand our architecture on the fly without having to make it, without actually doing anything manually, and also without adding further development time to how long it takes to actually do the ETL, because even though the architecture is more complex, you do exactly the same thing when you do your ETL. You declare relationship, that's it. We had a few challenges. I think I can, no, I'm not going to do those. They're just examples of the stuff that you run into when you start to structure your metadata. And one of the stupid things is that once you have role-playing dimensions, we had a simple rule of thumb to begin with that we applied to automation code, that if there's a relationship, then we're going to call the foreign key the same, or the name of the dimension that it does a lookup to is going to be part of the name of the foreign key column. And we just applied that logic. Now we had role-playing dimensions and we had multiple entities within our code that was called the same thing, and SYS just threw up everywhere. So those are some of the things that you run into. Luckily, we of course had some benefits from doing this. First off, these are some of the things that we did. Like I said, we can configure slowly changing dimension types on a column level. The customer can do it. We're happy about that because it's their responsibility to do it. We have automatic detection of load order. I didn't show that, as you can see. On the control flow level, there's a container called level 0 and level 1. Usually what you want to do, if you do a star schema, it's pretty easy. You load your dimensions first, and then you load your facts. But if you have a normalized enterprise data warehouse layer, you're really concerned with in what order you're going to load your entities. And if it's a manual thing, you're going to make errors. Based on the relationships that I talked about earlier, our code actually generates the load order for us. So that once you get to, I don't know, level 4, level 5, whatever is the case, there are all the entities that no other entities has any lookups to. So it helps a lot because we don't have these development cycles where just sudden the customer comes and says, oh, why are there unknowns everywhere? I don't like that. And oh, it's because you changed, you had this table applied, this entity is now has a lookup to this entity. You don't have to maintain that manually because you actually already have all the information that matters because you used it to something else. Now we use it to doing this. We have an independent master data management layer that we use for key mappings and so on, for golden record definitions, for defining the authoritative source system and so on. And we also use it to put all of our key sets, all of our business key columns is not necessarily on the entity table because they're not keys. They're down here where they belong. And everything that's in our enterprise data warehouse model and our data mart model is something that the customer actually wants to see. If you have 3 source systems to the same entity table and together they have 20 key columns, you don't want to put that into your entity table. But it was something we did on the fly later on in Sprint 5 or something like that. And if we just did that in a manual process, it would simply pull the carpet away under us. Now we're able to do it, and exactly the same metadata apply. We didn't have to change anything because that was just it. We changed the framework code. And again, automation of lookups is actually what's it all about when you automate ETL. That's the first thing you want to concern yourself with, because this is where it hurts once your architecture gets more complex. By automating, you don't have to change anything. And this is the last slide. Yeah, it's the last slide. Here are some concrete examples of where it has actually helped us. Not necessarily data warehouse functionality-wise, but more context-wise. I talked about you're able to switch features and architects on the fly. That's nice. We actually changed naming standards and naming conventions 3 or 4 times because the customers, they really want to do it right, but they just aren't sure how to do it. So we've changed it many times. Then they realized that another public agency has defined some standards on how to name your data structures when you are a public agency in Denmark, and then we had to switch to that standard. So now we couldn't call it FK or ID. Now they had to be syskey and ref for reference and so on. And we had to change a few lines of code. We generated our physical structures. They were now called this, the columns. And of course, our generated ETL matched the new correctly named columns. It would have been a nightmare to do that all the time manually. Both the physical and logical models change over time as we learn more about these domains. It, again, would have hurt a lot to do it manually. And another benefit is the sys that we generate is pretty large now, actually. And if it had been done by hand, it would have been a mess to look at anyway. So it's easy, and actually it means, because it's so well structured, the customer actually starts feeling comfortable looking at our sys packages. Not just the data that we provide them with, but then I'll go into sys and click and say, ooh, I can see this. It's well structured. Sometimes it is even structured alphabetically, because that's how we retrieve our metadata. And they really, really like that. So, yeah, any questions? I hope it makes sense.
I think there are free cups for everybody. Everybody asks a question until they run.
Yeah.
Another question.
Yeah.
I guess if the topic would be like object orientation, there would be sometimes you would like to override some. Where will you put the logic? How would you structure something? I want to do this manually, and I don't want the framework to touch this.
Yeah. Now, like I said, I've done automation of this for many years, and it's always the case. You have to do to begin with, your automation process perhaps ever doesn't automate every scenario that you can think of and that you're going to run into in this given project. So how do you apply manual logic when also automating, so that next time you automate, you don't override the manual logic that you actually applied? What we did in this project actually is 2 things. First, in our architecture, we put in view layers between every layer, so that once we load from our staging area to our enterprise data warehouse layer, we have a staging view layer where we can put some logic. And when we load from our enterprise data warehouse layer to our data mart layer, we also have a view layer. It doesn't have to be views, it can be tables, but it's simply a place where we can apply some logic. For instance, let's say you know that we always want to do this thing for this column from this source. And maybe there are many flows that's actually going to read from this table and use this column. You can then just apply the same logic to that column each time via your view layer. But you are also able to write manual views. You can just write SQL, put it into this, and of course, that isn't modular, that isn't searchable. That's crap and I don't like it. But it means that we can actually automate everything into our enterprise data warehouse layer. Everything that we can describe in our view layer is automated in our enterprise data warehouse layer. Sometimes then you might still have a need to do something. Let's say the customer knows that for this or these few entities, I want to apply some special logic. Or I want to have slow detection dimensions type 2 on these two entities. I'm not able to do it, actually I am, but let's say I wasn't able to automate that. And they needed it in a week or so. Then I would have to do something in my enterprise data warehouse load that wasn't something I could fix in a view layer. It hadn't something to do with data. It was data warehouse functionality. It was a pattern. So what we did in our Biml templates is simply we had the possibility to put in manual logic simply by calling a systask. So we have different places where we can either execute SQL or call a systask to do stuff. So, and it's very simple. We simply look in the library, and if there's a sys package which named the same thing as whatever I put into my metadata framework, it will be run at that point in my sys package. So we did two things. In the architecture, I have view structures to apply manual SQL logic, typically used for doing advanced business logic or pivoting columns and stuff like that. And if it's something that's data warehouse functionality-wise that requires it to happen while we load our enterprise data warehouse, add in places in your templates where you are able to execute manual sys packages. It's a simple, pragmatic approach. But we've actually used it and it helped us. And then later on, we were actually able to automate those things, and then it all got away. But we were able to continue our development process. So. Yeah? No?
And there's a third option too, which you'll see during my part. So you've seen here a lot of the what and the why plus a high level with the how. We're going to drill down into the how, and we're going to look at codes right after the break. And one of the things I'll show you is something called transformers that allows you to put whatever custom logic you want in there and inject your automation into custom logic. So we'll see the third option, which Peter didn't use because he was just using a bit helper piece, which didn't have that particular feature.
Exactly. Yeah?
You're talking about creating a new data warehouse. Do you think anything here is applicable to existing data warehouses?
It's a very good question. And I'm sure that Scott is very happy that you asked that question, because actually those transformers that he's talking about, he's going to, I think you're going to show, or you can just choose to show that. But in Mist, in this product, you're actually able to import an existing manually constructed sys package. But not only that, you are also able to apply standard patterns to existing manual sys packages. So we're going to see exactly that. And that's pretty cool. Yeah.
You talk about configuration. Maybe the question is quite stupid, because I am mostly I am a C# developer, not a SQL 90% of the time. But regarding configuration, is it possible to configure the same way that we developers are used to do today, via configuration files, or is it in the database, or is it injectable by dependency injections?
Yeah, I think actually I'm not a .NET developer or anything, so I don't know much about that. I tried it a bit. But actually, Scott mentioned sometimes, he can just do it again in this presentation, that a lot of the inspiration that Mist draws on, the development of Mist, is actually wanting to apply some of the same patterns that you do and some of the routines you do when you do software development to data projects, because they didn't have all those things. So yeah, with Mist it actually gets much easier to apply it. But you're right, it isn't something that database or data warehouse guys are used to thinking about, like regression tests or abstraction layers or all that stuff. We're not used to that. But I think this is sort of a trend towards thinking more like a developer and doing a lot of stuff in code instead of just, doing it manually in a graphical user interface. I hope it is an answer. Anyone? No? Then I think we have a break.